On this timeline, 66 million years looks calm until one final line drops straight to zero in a single day. For over 160 million years, dinosaurs survived volcanoes, climate shifts, and continental drift. Then something completely new arrived. This story is not about slow decline. It is about a world that wakes up ordinary and ends unrecognizable. The evidence begins far from the dinosaurs themselves, buried in stone, chemistry, and shock-deformed minerals. All around the world, the same thin layer appears, like a timestamp stamped into Earth's crust. Whatever happened that day was fast, global, and powerful enough to rewrite life's trajectory. The dinosaurs never saw extinction coming, because extinction, in this case, arrived within hours. So what kind of event can turn a thriving planet into a survival test in a single day? Long before the dinosaurs noticed anything wrong, a mountain-sized object was already locked on a collision course with Earth. This object was not fast by cosmic standards, but it was fast enough to end an era. Its origin traces back to the asteroid belt, a leftover fragment from the solar system's violent birth. Gravity does not rush, but once it decides, it does not let go. By the time the asteroid crossed the Moon's orbit, there was no avoiding impact. On Earth, the late Cretaceous world went on as usual, unaware it had less than a day left. The impact site was already chosen by physics: shallow seas, soft rock, and catastrophic potential. When the asteroid finally met the atmosphere, the planet itself became part of the collision. What happened next unfolded faster than biology could adapt, and faster than history could remember. The asteroid struck at tens of thousands of kilometers per hour, releasing more energy than every nuclear weapon ever built at once. In less than a second, rock behaved like liquid, and the crust of Earth briefly lost its solidity. The impact carved a crater nearly 200 kilometers wide in minutes. Shock waves raced through the planet, triggering earthquakes far stronger than anything humans have recorded. Near the impact, everything within hundreds of kilometers was instantly erased. The ocean did not absorb the blow, it amplified it. Megatsunamis taller than skyscrapers raced across entire ocean basins. But the deadliest effects were not the waves, the fire, or the earthquakes. The planet had been struck, but now it was about to strike itself. Trillions of tons of shattered rock were thrown beyond the atmosphere. Then gravity pulled it all back. As this debris re-entered, it heated the atmosphere like a global oven. For hours, the sky itself radiated heat, hot enough to ignite forests continents away. Wildfires erupted almost simultaneously across much of the world. Smoke and soot rose into the sky faster than rain could ever remove it. Within days, sunlight began to fade, not because of night, but because of ash. Photosynthesis faltered first, breaking the base of nearly every food web. The mass extinction was no longer about impact, it had become about starvation. And as ash circled the globe, the planet entered a darkness it had never experienced before. As firestorms faded, a colder and quieter killer took over. Sunlight blocked by ash caused global temperatures to plunge within weeks. This was not winter, it was an impact winter, sudden and severe. Plants already weakened by darkness now faced freezing conditions. Herbivores lost food first, then predators lost prey. Large animals suffered most. They needed too much food to survive the collapse. Many survivors shared the same traits: small bodies, flexible diets, and the ability to hide. Life did not end, but it was radically simplified. The age of dinosaurs was ending, but the planet was not done reshaping life. Extinction was not random. Survival followed hidden rules written by biology and chance. Body size became a liability when food disappeared almost overnight. Animals that could eat almost anything had a narrow but crucial advantage. Burrowing and sheltering turned the ground itself into protection. Freshwater ecosystems proved more stable than oceans or forests. Seeds, spores, and dormant life waited out the darkness. Birds survived, not because they were dinosaurs, but because they behaved differently. By the time sunlight returned, the winners had already been decided. The extinction was over, but Earth's recovery had only just begun. For months to years, Earth entered a phase unlike anything in its history. The oceans cooled, currents slowed, and marine food chains fractured. Plankton, the base of ocean life, collapsed almost completely. On land, forests took decades to return, leaving open ground exposed. Without forests, erosion reshaped entire landscapes. Insects, often overlooked, became critical survivors and rebuilders. Fungi spread across the planet, feeding on what extinction left behind. Life was not thriving, it was quietly restarting. And in this silence, evolution prepared its next experiment. With the giants gone, space opened, ecological, physical, and evolutionary. Mammals that once lived in the shadows began to explore new roles. Body sizes increased, diets diversified, and behaviors shifted. Birds filled the skies once ruled by winged reptiles. Plants responded too, spreading faster-growing species across the land. New forests formed, different from anything dinosaurs had known. Predator-prey relationships reset from the ground up. Evolution moved quickly, not because it wanted to, but because it could. The extinction cleared the stage, but the story was far from over. Everything we know about that day comes not from stories, but from stone. At this boundary, scientists found an element rare on Earth, but common in space. The same layer appears on every continent, marking the same moment in time. Shocked quartz crystals reveal pressures only an impact could create. Glass-like droplets frozen in mid-air tell of rock melted and thrown skyward. Beneath the Yucatan Peninsula lies the scar itself. Drilling into the crater revealed fractured rock, melted stone, and sudden collapse. These clues align across disciplines: geology, chemistry, physics. Together, they point to a single catastrophic day that changed everything. To understand the scale of that day, imagine the same event happening now. The initial explosion would exceed the energy of all human weapons combined. Cities within hundreds of kilometers would vanish instantly. Megatsunamis would cross oceans faster than warnings could travel. Global fires would ignite far beyond the impact zone. Within days, sunlight would fade, and temperatures would fall worldwide. Food systems would collapse before recovery could begin. Technology would not stop extinction, it would only witness it. The dinosaurs did not fail to adapt. No complex life could. Millions of years after the impact, Earth stabilized, but it was a different planet. New climates emerged, shaped by altered oceans and atmospheres. Forests returned, led by flowering plants that spread rapidly. Mammals diversified into walkers, swimmers, climbers, and flyers. Predators and prey co-evolved, building new balances from the ground up. The extinction created opportunity, but at immense cost. Every modern ecosystem carries this hidden legacy, including the one that eventually produced us. The last day of the dinosaurs was not just an ending, it was a turning point written by chance. Had the asteroid arrived earlier or later, the outcome could have been completely different. Dinosaurs were not failing, they were thriving until the moment physics intervened. Mass extinctions don't choose victims, they erase possibilities. Our own existence depends on that erased world. Earth will face similar tests again, not because it is cruel, but because space is active. Today, we watch the sky with knowledge that dinosaurs never had. But knowledge does not guarantee control. The last day of the dinosaurs reminds us how thin the line between dominance and disappearance truly is.